coming to you from Jezero crater on the surface of Mars. This is Mr. C.
8th grade, happy Thursday to you. Now, I've got to hurry today, and I want to make sure I prep you really well. I think I have already done a pretty good job, but that I prep you really well for your BFQ tomorrow. Huh? What? BFQ? What? BFQ? That would be a big fat quiz, or an ST, a small test. How many points? 20, 25. That's it. And last one, huh? Woohoo! Last one. Well, except for the semester exam, they're really big fat tests. So that would be an RBFT, a really big fat test, the semester exam. I'm going to get you ready for it. Today we're going to have to set aside our study guide. Probably aren't going to have time to dive into it any today. Perhaps tomorrow. And there's a second one that I've already copied for you on, it would be quarter number 3, all the tests. I've written the answers out, most of them. So, and then this Saturday when I come to school, I will do the same thing with quarter 4 tests. Write the answers, run off copies. You'll be all set. Hey, before I get into the review, don't forget that on Friday you have 10 SSRs due. Many of you have turned them in already, but if you haven't, their official due date is tomorrow. So make sure you get those in. OTAs, on-time assignments, huh? So make sure you get those in. Again, the topics for the test that you're going to have for tomorrow are up on RenWeb in the homework section Wednesday under homework notes, RenWeb. Okay? Don't forget, you can use a 3x5 for the quiz, small test, and you can use a 3x5 or a 4x6 for the semester exam. Okay? Good deal. So, all right, first, test topics for tomorrow. Newton's laws. There's 4 of them. Newton's laws. First is laws of motion. They involve motion. Now, I'm going to back up just for a minute and review with you what a scientific law is. It's a principle in science that you can always count on. It always works. That's a law, a scientific law. So if I ask you tomorrow, hey, a principle in science that whose principle is always true, always holds true. Oh, that would be a law. Right. Law. Yep. You can count on it, principle in science. All right, Newton's laws of motion. Hey, Mr. C, do they involve things that are moving? Yeah, because that would be motion. All right, the first law of motion, an object that is like this pen. See the pen right there. An object at rest, not moving, tends to stay at rest and not move unless acted upon by a force. My pulling it toward me. That's a force, right? Force, push, or pull. So an object at rest tends to remain at rest unless acted upon by a force. An object that's moving will tend to move in a straight line at the same speed unless it's acted upon by a force. Like if it runs into something. That notepad pushed back on the pen. It actually pushes back on the pen, applies a force to it. You run into something, hey, trust me, you're on your bike and you run into a wall, the wall's going to push back on you. Yeah, I wouldn't do that experiment. Just trust me. Yeah, it's going to push you. And painfully, perhaps. Okay, so an object in motion will tend to remain in motion in a straight line at the same speed unless acted upon by a force. Newton's second law of motion. Force equals mass times acceleration. So the greater the mass of the object, the greater the force. That was weird. The greater the acceleration of the object, how fast it's moving. That increases the force. If both of these go up, like I'm making them right now, if both the mass and the acceleration go up, then the force is really going to go up because you multiply those times each other. Oh yeah, mass times acceleration. Yeah. Mass goes up, force goes up. Acceleration goes up, force goes up. Both of them go up. They really go up because you multiply them together. F equals ma. Force equals mass times acceleration. Okay? And the third law of motion. Are you going to blow up a balloon today? Not today. Yeah, I know you would really like to see that and all. Okay? But for every action, say this way, there's an equal and opposite reaction the other way. So action, reaction. Rocket, jet engine, balloon, action, reaction. Equal and opposite. There's Newton's 3 laws of motion. Then there is the universal law of gravitation. Pardon me. And you know what it says, don't you? Here's what Newton said it says. Every object in the universe pulls on every other object. Universal law of gravitation. So, and I'm writing down the two variables that cause that attraction between the two objects to be greater. What would make two objects that are attracting each other have a greater attraction? Mass goes up. So I'm writing down mass. These are the variables that affect the universal law of gravitation. So see right there where I put variables, mass, and the other one is how close or the distance the objects are from each other. So I'm just going to abbreviate distance. And there it is right there. See that? The two variables that affect the universal law of gravitation. Masses of the object, more mass, more pull, more gravity. And closer to each other, more gravity, more gravitational pull. Further away, less gravitational pull. Then we've got a force. What's a force in science? A push or a pull. That would be a force. Push or pull. And then work is done on an object. Right now, see the object, the pen. Thumb up if work is being done right now to that object. Thumb up, yes. Thumb down, no. Mr. Phillips checking it out. Is work being done to this pen right now? A teeny weeny little bit of work, not much. Because for an object to have work done to it, it's got to be moving. Ah, now work is being done on this pen because it's moving. Now, you notice when I was holding it, you notice when I was holding it, I couldn't keep it totally still. So there was a teeny weeny bit of work being done or applied to the object. Okay? So, and then there is, I think I've actually got, do I have this to show you? Ah, yes, here it is. So, I'm going to ask you tomorrow what the formula is for how much work is done. There it is. Work equals force times the distance. The force applied to an object and the distance it moves. So W equals F times D. Work equals the force on that object times the distance it moves. And then I have some sample problems. So I'll give you one sample problem on the quiz. So here's a sample problem right there. The force that was applied was 5 kilograms. You multiply that times how far it moves, 6 meters. 6 times 5, 30 Newton meters, we call them. And the other word we use instead of Newton meters is J for joule. J for joule. 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 Now, I want you to write this down. Write this down. What 1 joule equals. 1 joule equals the object weighing 1 kilogram, moving 1 meter in 1 second. 1 kg, that's 2.2 pounds. An object that weighs 2.2 pounds, 1 kilogram, it moves 1 meter in 1 second. Ah, that is a joule. The standard unit for how much work occurred. A joule. So now, I don't know if you want to think J-E-W-E-L and then just remember the alternate spelling. Joule. 1 joule. Say it to yourself. What does 1 joule equal? Visualize it. Say it to yourself. You don't have to say it out loud, but you can. An object that weighs 1 kilogram and it moves 1 meter in 1 second. That's 1 joule of work. That's what it is. And I'm going to ask that. So I'll ask you what a joule is. 1 kilogram moving 1 meter in 1 second. 1 kilogram moving 1 meter in 1 second. 1 joule. Okay? Hey, here's a work problem. Do it in your head. So see if you can. So let's say we want to know how much work was done to this object. Let's say the object I'm talking about weighed 10 kilograms, 22 pounds. 10 kilograms. So 10 kilograms. And let's say it moved 10 meters. So how many joules of work? Easy peasy. 10 kilograms times 10 meters. What do you get? 100 Newton meters, or 100 J for joule. 100 joules. You just multiply the two numbers times each other, and that's the number of Newton meters, aka joules. Okay, so did I miss anything? Let me see if I did. Got to look over my legal pad. I want to make sure that I've properly prepared you. Oh, there'll be TED Ed questions too from the TED Ed video on practice. The tips you can do to practice properly. No distractions. Don't be on your phone. Don't be playing video games. So don't be listening to really loud music. That probably would distract you. Just concentrate, focus on what it is you're trying to learn. So no distractions. Number 2, the people who practice best take frequent breaks from their practice. Maybe practice 15 minutes really hard and then take a break. 5-minute break, 10-minute break. When you study for the semester exam next week, even this week, but more next week, so why don't you aim for 10 or 15-minute practice sessions, study sessions, and then take a little break. Research shows you will learn better. Your learning will be enhanced. It'll be sooner. So concentration, no distractions, frequent breaks. Visualize in your brain what it is. Like visualize right now in your head what 1 joule is. Just visualize it. What is a joule? 1 joule equals an object moving 1 kg, 1 kilogram. And then, so 1 joule equals an object weighing 1 kilogram moving 1 meter in 1 second. And that's 1 joule. Okay? So you're visualizing. And then practice frequently, frequent practice sessions during a day. Not 1 or 2, but many. The very best learners practice frequently. And then practice properly. Now, I don't know exactly. I had a friend who was a volleyball coach, and I remember him saying there was some kind of proper way to hold your hands if you're a setter in volleyball, and trying to set the volleyball softly and high enough right in front of the net so the hitter can really, smack it. And I realize there's a way to hit too. I don't know exactly what it is, but I know there is a way that you girls who are volleyball players have been coached, or you guys who play volleyball, if you've been on a team and been coached, how to set, how to hit. Okay? So if you don't practice the right way to set, you won't do it right and you won't be as successful as a setter. Or if you don't practice the right way to hit a volleyball, you won't be as successful. So anyway, so the TED Ed stuff will be on there as well, and it'll be up on RenWeb. Now, my daughter Laura has promised me this. By the time I go out to school on Saturday, she'll give me a study guide she'll type it up, of things that she has wanted you to remember, she's taught you this year. And there'll be some of those on the test. So she's going to come in and wind up creativity. So on your study guide, say on the back of your study guide, you've got a lot of room there. Write down 2 or 3 tips that she's going to give you about how to enhance your creativity. Now, when I was in 8th grade, if you'd have asked me, hey, Craig, are you very creative? I would have said, no, not really. But you can't say that. We can't say that. We've got creativity inside of us ready to pop out. Every one of us. It's part of our made in God's image, that list. Creativity. Great potential for creativity. She's going to give you tips on how to develop that creativity. So, and this is one of my favorite topics that she does, so probably 1 or 2 of these will be on the final. I could do 2 and they'd be worth half a point each. Just ways to enhance, improve your creativity. Write them down here, and Laura is on.
This is Your Magnificent Brain, Learning with Laura, and I did say that last week was going to be my last official lecture, but it ended up we needed to cut a few things from my creativity lecture. So this is really creativity part 2. It's things that I mentioned in context of last week's conversation, but it's more the practical side of creativity. Some of the things you can do and some of the things to consider. So I will start this conversation, start picking up this lecture at a very powerful question that's very useful to creativity. And that's the question, what if? Enjoy. What if? Asking the question, what if, is a really powerful part of the creative process. Just thinking about when you have something that you're working on, what if we did this? What if it looked like this? often creativity is just being able to shove yourself out of your own viewpoint and look at it from another perspective. Shoving yourself out of how it's always been done previously and saying, well, yes, it's been done that way previously, but how could it be done? If this were to change, would it make the process smoother? If this part was combined, if this step was combined with something else, if we challenged what's, the normal, typical rules of how we work, could something new be created, something interesting and something innovative? And then just some general recommendations for creating and how to prep your mind to be able to create and to be able to kind of think innovatively. Paying attention to the world around you and seeing everything that you interact with, even if it's in different areas, seeing that as kind of food for your creative process. So if you learn about new techniques in one area, there's always the possibility that those techniques or those innovations in one area might apply to your area. In any case, even if they don't, it helps you look at things from a different perspective. Listening to people who have creative solutions helps your brain kind of start getting in the habit of thinking creatively. Often listening to how they work creatively, how they generate ideas, how they push themselves, exercises for pushing themselves out of just the normal standard thought process can be really helpful regardless of what area you're in. My area of expertise is in psychology and in teaching and kind of testing, and also in writing. So using different things that I've learned in one area has actually been very useful in others. For instance, how people think has been so useful. All of that I learned in psychology, and even how people learn, how people interact with data, has been really useful to writing. So just because something is not in the same area, kind of release yourself from that. Allow yourself to think of, well, this is true in this area, could it be true in this one? Part of creativity is actually testing boundaries and pushing boundaries out of what's possible. Whenever we see, especially in science, I think it's really, you can see different areas in which they've learned new things. For instance, some of what you've been learning this year, I'm sure, has involved like the atom. And what they've learned about the atom over time has just grown exponentially as they studied it. But someone had to have the idea for how to study the atom in new ways over time. And reminding yourself that anything we know took that time, that innovation, that looking at techniques that were previously considered to be standard and pushing those boundaries of what's possible out. Everything that we interact with, everything we learn, from what we decide to do, what we decide to study, and what we decide to, do for fun, even as a hobby, we have the ability to push the boundaries of what's possible. And even understanding where our own personal limitations are, what areas we can get into and really use our knowledge to push in certain ways, and areas where we might not be in a position to be able to do that. Acknowledging both those things, limitations of what is a real limitation, what can we push past, and what's something that we would need to invest some more time in kind of gaining capacity before we attempted to move that barrier back. I think re-challenging what the rules are in a given context is a powerful tool in being able to see what solutions could be. Even redefining what it is you're attempting to do can be powerful. And then lastly, thinking creatively and sharing ideas put you in a position of being vulnerable. Often you're holding up something that is a product of your mind for someone else to look at and to judge. And what I'd say is learn about and understand the circumstances in which being creative and offering up innovative solutions are helpful and beneficial, and other situations in which you might want to either consider how you frame it from a context perspective, consider who you go to with it to review it. Make sure that it's not someone who will have a gut reaction to it and just shut it down without considering, without being open to the ideas. Because often when we're in a vulnerable position, when we take that risk and share it with someone, if it's rejected, it can have a very painful repercussion to ourselves and even to our being creative in other situations. And if that happens, if at any point your creativity or your work is rejected, I've personally found it useful to just remind yourself that not everyone is ready to make changes, to transform a process, and realizing that your ideas might not be for everyone, but having creative and innovative ideas are valuable, they're powerful, and they can actually change the world, potentially. And remembering that just because someone rejects your idea doesn't mean that you don't have good ideas. It's good to continue to remind yourself that it's just that one experience. Reminding yourself that your creativity is valuable, even if not everyone really respects it or responds to it positively. One of the things that I've found most helpful with my own ideas is making sure that I have a journal just by my bed or on my desk, where whenever I have an idea, no matter how I value it, from a judgment perspective, I always write it down, because then once that idea is written down, one, you have it recorded in case you ever need it and you're like, oh, what was that idea I had? But two, it also frees up your brain to be able to come up with other ideas. So if you naturally come up with ideas in the middle of the night, or when you first wake up in the morning or right before you go to bed, it's there so you can record it, and you can make sure that any idea that you have, regardless of its merit, not everything that you come up with is going to be the best idea in the world. Some of them might be ones that all you ever do is write them down and you look at it once in a while and like, oh, that was different. But by doing that, by exercising that creative skill, that creative muscle, by thinking outside the norm, you potentially can use those ideas to generate unique and creative solutions. I also wanted to leave this lecture with stating that, I'd mentioned previously that I have dyspraxia, which means that I see the world differently than other people. My brain tends to work differently. I have right-left confusion where sometimes I have to take more time to consider my directions, or a P and a D, or a P and a 9, a D and a B could get swapped in my brain. It's just how my brain works. But often with learning disabilities, there is some research that suggests that there is a correlation between what is considered to be a learning disability and also the ability to think creatively, to be able to think originally, and also to be able to have coping mechanisms for kind of working through difficult problems. I'm not saying that they're connected in that one causes the other, but I'm saying that there's a relationship. So it doesn't prove causation, but there is a relationship between the two. There's a correlation between having a different kind of way of viewing the world, the ways in which your brain works, and being able to make creative connections. That, I think, is important to remember, that learning how to push through when something gets difficult, when you have to take that extra time to learn something, it ends up being worth it. So I leave the lecture there, where we talk about how the way your unique brain works can help with creativity. And I mean that as using an example for how each and every one of us has a brain that works differently, and that those are the things that can help us come up with truly unique, creative, boundary-pushing ideas. So I hope you have a great rest of your week. I will be back next week to talk about some of the things from my lectures that will be potentially on the exam. And again, I would encourage you to find new ways to learn, grow, expand your knowledge, and to find opportunities to be creative and to think outside the box. Bye for now.